Good afternoon, everyone. Thanks for all being here today. My name is Yifan, a PhD student from Michigan Tech. My supervisor is Dr. Xiao. I'm excited to share my research on the understanding cognitive impact of robots in worker-robot collaboration in modular construction. Let's start with the background. So modular construction is changing the traditional building ways. Instead of building everything on site, the modular construction moves most of these works into the controlled factory settings. So here the building components are prefabricated and then transported to the construction site for the final assembly. Modular construction has a bunch of benefits such as the enhanced efficiency, quality, safety, and sustainability. Recently, robotics has been widely used in our industry. The semi-structured of the modular construction makes it a great match for the robotic applications with these benefits such as the enhanced efficiency by automating repetitive tasks. They provide better precision and quality control and reduce costs over time. So even with robots, the full automation is still a long way. So human-robot collaboration, or HRC, will remain a key phase. However, working with robots places additional cognitive challenges to human workers. So if we ignore these effects, it may hurt the workers' mental and physical health. Most existing studies focuses on maximizing the productivity, but they often overlook the cognitive impacts. So some studies on examining the robot impacts, they often use methodologies such as questionnaires, interviews, simulations, and sensor-based approaches with limited integration of cognitive theories into the prediction of robot impacts, especially for the cognitive impact. So this study will propose a comprehensive methodology which combines the self-report questionnaire and the controlled experiment to measure the cognitive impact on both working performance and human factors. We also use the T3 model to predict such impact. So what's the T3 model, which is the task, taxon, task methodology, which is a predictive model for assessing the impact of a stressor on the task performance. So it begins with measured effects of a stressor on tasks, then uses statistical inference to identify the impact of those stressors on the hypothesized skill taxon, and finally uses those taxons to make predictions on new tasks. To do this, the main objective is to quantify and predict robot cognitive impacts. The first objective is to quantify the cognitive impact on working performance and human factors. The second objective is to predict such impact on working performance. To do this, a 6-step methodology is proposed. For modular construction tasks, we first break it down into the subtasks, and then we can define the stressor. In this case, the stressor is the presence of the robot because we will examine its impact. So the two experimental groups are designed. In the baseline group, the human will perform all these subtasks. Under a cobot condition, the human will perform the same tasks, but the robot working nearby them. Then we define the skill taxonomy, which is called taxon, which is the mental and physical skill of humans, which is required for these subtasks. Then we can analyze the task taxon loadings, which reflects the different skill demand across these different subtasks. Then we run the controlled experiment to collect the data so we can assess and predict such impact using the mathematics model such as linear regression. The main tasks we used in this study is the wooden wall panel manufacturing. As shown here, the human will work on the left side, while robot working right next to them. There's no overlapping between their working areas to make sure safety. In the baseline group, the robot will turn off, and while in the cobot conditions, the robot will repeatedly perform the pick and place subtasks, which is subtask 1. On this table listed all the devices, materials used in these studies. We used the UR10E robotic arm with a robotic 2-finger gripper. A total of 10 undergraduate students from Michigan Tech are recruited in this experiment. 6 males, 4 females. They all met the health and experience criteria, which is approved by the IRB. To measure the working performance, these 3 metrics are used. The time efficiency, the task completion time, with log transformation for the linear regression. And secondly, is angular accuracy, measured as the total accuracy of the joint from joint 1 to joint 8. And screen quality is calculated as a percentage of the failed screws. To measure the human factors, we use the self-report questionnaires, which is administered before and after the entire process of the all 9 subtasks, including the physical and mental fatigue, physical and mental effort, and stress state. The results show that time efficiency, the subtask 5 and subtask 6 are significantly different with the others. And the angular accuracy and angular accuracy decreased a little bit. And mental fatigue, mental effort, and distress increased under the robot impact. So these findings highlight that the robot do influence human workers, especially in time efficiency, mental fatigue, mental effort, and distress. These findings also support to use the T3 model to predict such impacts. To employ the T3 model, so we use the linear mixed effects model to collect the data and leave one subject out cross-validation to justify the predicted performance. The results show that the proposed model achieved an average accuracy of 87.5%, which provides an explainable way to predict such impact. We also explored how the spatial distance between robot and human influence the cognitive performance of the human workers. So an extra experimental group are designed, which changes the robot proximity from 0.2 meters to 1 meters. The results show that keep a safe distance, in this case it's 1 meter, can significantly reduce the mental effect of the robot. So to conclude, when we employ the robot application in our industry, we should consider both productivity and the cognitive responses to human. And keeping a safe distance can significantly reduce these cognitive impacts. Finally, using the proposed framework, the cognitive impact of robot can be modeled and predicted. It's a reference.
Okay, thank you very much.